A 320 amps meter can feed two separate 200 amps panels. Panel A remains connected to the meter, while panel B will receive power from an automatic transfer switch connected to the generator. The setup begins with the meter can, which is rated for 320 amps. From the meter can, there is a 200 amps disconnect located outside the house. This disconnect feeds a 2-pole 200 amps automatic transfer switch. One output of the automatic transfer switch connects to panel A, which is a 200 amps panel directly connected to the meter can. The other output of the automatic transfer switch connects to panel B, also a 200 amps panel, which will be powered by the generator when utility power is lost. Since panel B is not directly connected to the meter, it is considered a sub-panel. In panel B, the ground and neutral conductors must be separated. The ground bus bar should be connected to the metal enclosure of the panel, and the neutral bus bar should be isolated from the enclosure. When transferring circuits from panel A to panel B, wire nuts or other approved splicing methods can be used to extend the wires. All splices must be accessible for inspection and maintenance. Splices can be located inside panel B if there is sufficient space. If there is not enough space inside panel B, splices can be located in an external junction box mounted on the panel. This junction box must be listed for the purpose and meet all applicable codes. Ensure that all circuits in panel B are properly protected by circuit breakers or fuses. The size of the circuit breakers should be appropriate for the ampacity of the wires and the loads they serve. Calculate the total load that will be powered by the generator. This calculation will help ensure that the generator is properly sized to handle the load. Consult with a qualified electrician to ensure that the installation meets all applicable National Electrical Code requirements. A qualified electrician can review the plans, inspect the installation, and provide guidance on any code-related issues. Obtain any necessary permits from the local authority before starting the installation. Permits are typically required for electrical work, and they help ensure that the installation is safe and compliant with local codes. To further clarify the requirements, let's delve deeper into specific aspects of the generator installation. Firstly, the selection of the automatic transfer switch is critical. The automatic transfer switch must be rated for the maximum current that will flow through it, which in this case is 200 amps. It should also be listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets safety standards. The automatic transfer switch should be installed in a location that is accessible for maintenance and protected from the elements. Secondly, the wiring methods used for the generator installation must comply with the National Electrical Code. For example, conductors must be sized according to their ampacity, and they must be protected from physical damage. Conduit or cable armor may be required in certain locations. All wiring connections must be made in approved enclosures, and grounding must be done in accordance with the National Electrical Code. Thirdly, the grounding system for the generator and automatic transfer switch must be properly installed. The grounding electrode system should consist of a ground rod, ground plate, or other approved grounding electrode. The grounding electrode conductor must be sized according to the National Electrical Code, and it must be connected to the grounding bus bar in the panel. The generator frame must also be grounded. Fourthly, the overcurrent protection for the generator and automatic transfer switch must be properly sized. The circuit breakers or fuses must be rated to protect the conductors and equipment from overloads and short circuits. The overcurrent protection devices must be readily accessible and labeled. Fifthly, the load calculation for the generator must be accurate. The load calculation should include all of the loads that will be powered by the generator, including lighting, appliances, and equipment. The load calculation should also take into account any demand factors that may apply. The generator should be sized to handle the total load, with some additional capacity for future expansion. Sixthly, the installation of the generator must comply with all applicable codes and regulations. This includes the National Electrical Code, as well as any local codes or ordinances. The installation must be inspected by a qualified electrician to ensure that it is safe and compliant. Seventhly, the generator should be tested after installation to ensure that it is working properly. The test should include a check of the generator's voltage, frequency, and output power. The test should also verify that the automatic transfer switch is functioning correctly. Eighthly, the generator should be maintained regularly to ensure that it continues to operate reliably. The maintenance should include checking the oil level, cleaning the air filter, and inspecting the spark plugs. The generator should also be exercised periodically to keep the engine lubricated and the electrical components functioning properly. Ninthly, it is important to understand the specific requirements for separating the ground and neutral conductors in panel B. This separation is required because panel B is being treated as a subpanel, and the National Electrical Code prohibits the bonding of ground and neutral conductors in subpanels. The purpose of this requirement is to prevent neutral current from flowing on the grounding conductors, which can create a shock hazard. To separate the ground and neutral conductors in panel B, you must remove the bonding screw or strap that connects the neutral bus bar to the panel enclosure. You must also ensure that the ground bus bar is properly connected to the panel enclosure and to the grounding electrode system. Tenthly, when extending circuits from panel A to panel B, it is important to use the correct size and type of wire. The wire must be rated for the ampacity of the circuit, and it must be suitable for the environment in which it will be installed. You should also use approved splicing methods such as wire nuts or crimp connectors to ensure that the connections are secure and reliable. All splices must be accessible for inspection and maintenance. 11thly, the location of the splices is also important. If there is sufficient space inside panel B, you can locate the splices there. However, if there is not enough space, you can locate the splices in an external junction box mounted on the panel. The junction box must be listed for the purpose and meet all applicable codes. It is also important to ensure that the junction box is properly grounded. 12thly, it is crucial to consult with a qualified electrician throughout the generator installation process. A qualified electrician can provide valuable guidance on code compliance, safety, and best practices. They can also help you avoid costly mistakes and ensure that the installation is done correctly. 13thly, obtaining the necessary permits is essential. Permits are required for most electrical work, and they help ensure that the installation is inspected and approved by the local authority. The permit process may also involve submitting plans and specifications for the installation. 14thly, consider the location of the generator itself. It should be placed in a well-ventilated area, away from combustible materials, and protected from the elements. Follow the manufacturer's recommendations for installation and clearance requirements. 15thly, ensure proper labeling of all components and circuits. This will help with future maintenance and troubleshooting. Label panel A, panel B, the automatic transfer switch, and the generator. Clearly identify the circuits that are powered by the generator. 16thly, it's important to understand the concept of load shedding. Load shedding is a technique used to reduce the amount of power that the generator needs to supply. This can be done by selectively disconnecting non-essential loads such as air conditioners or electric water heaters when the generator is running at its maximum capacity. 17thly, consider the use of a remote monitoring system for the generator. A remote monitoring system can provide real-time information about the generator's status, including its voltage, frequency, output power, and fuel level. This can help you detect problems early and prevent costly repairs. 18thly, be aware of the noise generated by the generator. Generators can be quite noisy, so it is important to choose a location that will minimize the impact on neighbors. You can also install soundproofing materials around the generator to reduce the noise level. 19thly, consider the fuel source for the generator. Natural gas generators are typically connected to the natural gas line, while propane generators require a propane tank. Ensure that you have a reliable fuel source and that the fuel supply is adequate for the generator's runtime. 20thly, it is essential to have a written emergency plan in place in case of a power outage. The plan should include instructions on how to operate the generator, how to transfer loads, and how to contact emergency services. The plan should also be reviewed and updated regularly. These additional considerations should help ensure a safe, compliant, and reliable generator installation. Remember to prioritize safety and consult with qualified professionals throughout the process.